All right, we're back. So this is video number 2. I'm just picking up where I left off. So what we're going to do now is we're going to do a couple examples using dimensional analysis. All right, and these are things that you've probably done before doing unit conversions, but I want to show you the approach. So this is really, really important. This is the core. You're going to build on this, and this is learning how to do dimensional analysis will just give you a second problem-solving tool. And as you progress, you're going to find some problems are best done using algebra. Some problems are best done using dimensional analysis. Now, how do you know which one to use? To be honest with you, it's experience. So you try a problem one way and it's really hard, try it another way and it's much easier. Then remember, next time you see a problem like that, do it that way. So it's okay. This is where you learn by making mistakes. So if you try something and it doesn't work out, try it a different way and it works. That's how you learn. You learn a lot more from making mistakes, honestly, than you do from just getting everything correct. So let's do a problem together, right? So walking through this, how many meters in 24.7 centimeters? Now again, if you grew up, you just know how in an area, you know this, you know the metric system, you know you can just kind of do this in your head, but I want to show you the approach, right? So to set up the problem, we're going to set it up like this. We want 24.7 centimeters, we want meters. Also, you know a meter is bigger than a centimeter, so this should be small, the answer. So now what we need is a relationship for the units, and basically dimensional analysis is like multiplying fractions. So we're going to need centimeters to cancel, so it needs to be in the denominator, and we're going to need meters on the top. Right? So we're looking for the relationship between meters and centimeters. And now, where do you get this? Well, you look it up. If you've memorized it, you're looking it up in your head. And if you haven't memorized it, you look it up on a sheet of paper. But again, for an exam, you're going to need to know this. Okay, this is not only about 5 of them. Now we put in the numbers. We know that 1 centimeter is 10 to the minus 2 meters, right? And then we do the math, and you see how the units cancel. Then 24.7 times 10 to the minus 2 is 0.247. And does my answer make sense? Yes, a centimeter is much smaller than a meter, so yes. You see the approach? That's what you want to be able to do, right? Here's one that's a little bit more complicated, right? So we're going to go, a hint that you may need more than one step. If you look at this problem, see how we're going from a unit with 2 letters to a unit with 1 letter, or vice versa? Probably can do this in one step because we know the relationship between the one with 2 letters and the one with 1 letter. This one, though, we want to go from 1 with 2 letters to 1 with 2 letters. So that means we're probably going to have to go to the one with only 1 letter, grams in this case, in between. Again, just to walk through this, we'll set up the problem. 38.65 kilograms. Going to go to milligrams. So ideally, we would have this relationship between milligrams and kilograms, but we don't know that. And again, like I said, any unit with 2 letters can be related to those with 1 letter, so we can relate kilograms to grams. Kilo, how do you kilogram? 1,000 times. Milli means 10 to the minus 3rd. So if we go to this next slide, right, we'll make the kilograms cancel. How do we do that? We put kilograms on the bottom, and then we know that a kilogram is 10 to the 3rd grams. But now we have grams. We still want milligrams, so we're not done. And you see, if you don't label the units, you won't realize that. That's why it's really important. It's much harder to make mistakes if you put units on. All right? So now we need the relationship. We want milligrams on the top, and we want grams on the bottom. If you cancel as you go, it means we don't have to worry about kilograms anymore. Okay, so then we see milligrams per gram. Oh yeah, I know that one. A milligram is 10 to the minus 3rd grams. And then we do the math. And it's good, try these on your calculator to make sure you can get the right answer. You should get 3.865 times 10 to the 7th. And so you put this in your calculator, it would be, if I can do this, can I draw with this? Let's see if I can draw with it. No, I can't. I'd have to go into another mode. But you would put 38.65 times 1e3 divided by 1e minus 3. That's how you would do it on your calculator. Does it make sense? Yes, kilograms are much bigger. Kilograms about 2 pounds. A milligram, there's 500 of them in an aspirin, right? They're very small. All right, now, Even more powerful, you can do a problem completely backwards. And this is what I mean, because you always know part of the answer. So this is not a chemistry problem. You can read this yourself, but you decide to visit your dear cousin Candace, who lives this many 1,587 miles away. Your car gets 28.4 miles to the gallon. Gas costs $3.10 per gallon. How much money do you need for gas, right? And this is something you may have to do. You may decide to go visit someone and drive there, and you're on a budget because you're not independently wealthy, and so you might want to know, well, how much gas am I going to need? But you've got 3 different numbers here. Which one do I start with? How do I start this problem? Most students have told me over the years the hardest part, if I could just set up the problem for me, I can totally solve it. So this is where there's some hints in here to help you solve the problem. So going to the next slide, just to show you the approach. And again, this is what the most important thing is this approach to problem solving. So I don't know, right? I've got 3 numbers here. So let's do this. Well, what do we know? We know the answer is going to be how much money do you need for gas? So money is measured in dollars. So we want to get the unit dollars by itself at the end, right? Because it's not dollars per mile, it's dollars. So then we look at the numbers. Well, where do I have dollars? I have dollars right here in the $3.10, and it's in the numerator, so I'm going to stick that in the problem. Okay? $3.10 per gallon. Now the gallon is there, I can't just not write it, but that tells me that 310 is in the top, gallons are in the bottom. So now what we have to do is I have to make gallons go away. I don't want to use this number because I've already used it, but we look, where do we see gallons? We see gallons here, but it's in the denominator. Here it's in the denominator. We want it in the numerator to make it cancel. So where else do we have it? Right here. But what we're going to do is we're going to flip it over. Right? So there's an implied one here, so we know that 1 gallon is 28.4 miles. And again, why am I writing it this way? Because I want gallons to cancel. So I have gallons on the bottom here, and I don't want gallons, so I'm going to put it on the top. If I put gallons on the top, the 28.4 goes on the bottom. Right? So now gallons cancel. Am I done? No, I'm not done. Right? Because if I stop now, I'd have dollars per mile, which is cute and all, but it's not what I was asked. So I have to make miles cancel. So what do I want? I have miles here in the denominator. I want it in the numerator. So I'm going to put the 1587 in the numerator. And then I just do the math. You see how the mile, I forgot to cancel it here, but miles cancel. Right? So I go 1587 divided by 28.4 times 310. That'll give me 173. So the idea here is if you were to come to my office with a question like this, I'm not going to tell you the answer. What I'm going to do is I'm going to ask you easy questions that you can answer that will lead you to the big answer, right? Easy questions like, what are the units of the answer? Where do I have that unit? Okay, now what have I done? Do I have to cancel something? So all you need to learn how to do is to ask yourself the questions that I would ask you. So the idea is, that's why working backwards is powerful, because you know, it almost tells you what the next step is, almost. All right? So I'm going to give you a minute, try this one on your own, and then you can hit enter for each step. All right? So you're going to go from 387 millimeters to micrometers or micrometers. Okay? You have to know milli and micro. So hit pause, try it on your own. Okay, did you try it on your own? Just hit pause. Okay, now we're unpaused. I'm going to walk you through it. So the questions I ask, right? If you're going to learn to ask yourself the right questions, what will be the units of the answer? Micrometers, right? And in this case, we only have one number, so we know we're starting here. Now, I'm going to do this backwards, but you can do it forwards. If doing it forwards, I have to make this go away. Doing it backwards, I have to make this appear. So let's do this backwards because that's probably newer to most of you. So what do I know about micrometers? Well, I know that 1 micrometer is 10 to the minus 6 meters. So I want micro in the top, right? Because it's in the top here. So now what I have to do is I have to make millimeters and meters cancel. And of course, I know the relationship because this says 2 letters and this only has 1, right? Why did I choose to relate it to meters? Because that's the only thing I know about micrometers. So now I want to relate these, and I want millimeters on the bottom, and I want meters on the top. And there you go. I know that 1 millimeter is 10 to the minus 3 meters. And then I do the math, and again, 387 times 10 to the minus 3 divided by 10 to the minus 6, all right, which is 387,000 micrometers. All right, so that's what you want to be able to do. We're going to do a lot more with this. I'm going to have a whole set of slides where we're just going to do something. I'm just going to walk you through about 6 types of problems, and we're going to have some problem solving sessions in our synchronous sessions on Mondays. I'm going to stop here on this, excuse me. Well, let's do this. Let's do volume, and then we'll stop this video. My bad. Okay, so one more thing. Volume, SI unit of volume is the liter. It's defined as the volume in a box that's 10 centimeters on the side, right? As far as volume formulas, I think knowing a rectangular solid is reasonable. Other ones I would give you, all right? So we know for a rectangular solid, this is by definition. The volume is length times width times height, which in this case is 10 times 10 times 10 centimeters. So 1 liter is 10 to the third centimeters cubed. So centimeters times centimeters times centimeters is centimeters cubed. Kind of handy. 1 milliliter is 10 to the minus third liters, right? So that means you can also rearrange this, multiply each side by 10 to the third. So 10 to the third milliliters is a liter, but a liter is also 10 to the third cubic centimeters. So knowing that a milliliter is a cubic centimeter is kind of handy. Now, with dimensional analysis, anytime you're doing units, if you raise the unit to a power, you raise the number to a power. So for example, if I'm going to go from 1 millimeter, right, knowing 1 millimeter is 10 to the minus third meters, if I cube this, I would cube this. So 1 millimeter quantity cubed is 10 to the minus third meters, quantity cubed. Remember, if you bring the exponent through, so cubed. So 1 cubic millimeter is 10 to the minus 9th cubic meters. This you have to know. This you can figure out. I'm going to do one calculation with this, and then we'll stop this video. All right, so a tank is 5 meters on the side. What is its volume in liters? Let's just walk you through this one. You can hit pause and try this on your own. So the first thing, let's get the volume. Okay. So the volume is, again, 5 by 5 by 5, and then meters. It's 125 cubic meters. So we want to convert 125 cubic meters to liters, and I don't know that relationship. So let's work backwards. What do I know about liters? Right? Again, you can hit pause at any step and try it on your own. Okay, well I know 1 liter is 10 to the third cubic centimeters from this slide right here, right? Let's get back to where I was. All right, so now liters are there, but I need cubic centimeters and cubic meters. Now I don't know that, but I do know that 1 centimeter is 10 to the minus 2 meters. 1 centimeter is 10 to the minus 2 meters, but I want it cubed. I don't just cube the unit, I cube the number with the unit. So it's 1 centimeter quantity cubed, 10 to the minus 2 meters quantity cubed. I don't know if I did this. And this, now you do the math. This is 10 to the minus 6, so 125 cubic meters divided by 10 to the minus 6 cubic meters divided by 10 to the third is 125,000 liters. All right, I'm going to stop the video here, and we'll do another video for the rest of these slides. I'm going to do more problems, as I said, in a separate slideshow, where we're going to practice with this stuff and do some stuff that's got a little bit, just more practice. It won't be any really new material, a couple new things, new material, but not much. But for now, I want to finish these slides. So take a break. Word from our sponsors.